Strong acids fully dissociate in water, which means that all of their acid molecules donate their H plus ions to water. For example, HCl will fully dissolve into H plus and Cl minus in water.
Weak acids only partially dissociate in water, meaning that only a few of the acid molecules will donate their H plus ions to water. For example, acetic acid will only partially dissociate in water.
This partial dissociation of a weak acid leads to the development of an equilibrium reaction, as since the acid is not fully dissociated, the reaction can be reversible. Equilibrium is only possible for weak acids and not strong acids, since strong acids dissociate completely.
To minimize the effect of weak acid equilibrium, there are some steps you could take, including increasing the concentration of weak acid, making the solution more acidic, and adding a strong acid. All these steps will cause the weak acid equilibrium reaction to shift and not be at equilibrium anymore.
A buffer is a solution that can resist the change of pH when small amounts of H plus or OH minus ions are donated to the solution, and it does this by neutralizing these ions.
A pH buffer consists of a weak acid and its conjugate base. The acid will donate H plus ions when the solution starts becoming basic, while the conjugate base will accept H plus ions when the solution starts becoming acidic. This helps to maintain a stable pH by counteracting any pH changes in the solution.
First, to prepare the meter, rinse off the pH meter with distilled water over a waste beaker. Then place the pH meter into the pH 7 buffer solution while slightly stirring, and make sure the bottom of the pH meter does not touch the sides of the beaker. The pH meter should record a pH of about 7. The pH recorded here is about 7.27.
Take the pH meter out of the beaker with distilled water and rinse the pH meter off with distilled water. Then place the pH meter into the pH 4 buffer solution. The pH meter should read the pH of the buffer at about 4. The pH recorded here is about 4.08.
Be sure to repeat this process at the lab when using the pH buffers again for measuring the pH of a different substance. The pH read for this buffer solution is about 7.02.
Be sure throughout this process to rinse off the pH meter after and before each use if needed.
Remove the pH meter from the beaker with distilled water and place it into a beaker in the dilution series made from the stock solution with an unknown pH. The pH of this solution is about 2.65.
Remove the pH meter from the beaker with DI water and rinse the pH meter with DI water over a waste beaker. Then place it into a beaker in the dilution series. This solution has a pH of about 3.21.
To test the pH of hydrochloric acid and tap water, first take the pH meter out of the beaker and place into the beaker with the HCl and tap water. Swirl slightly. The pH for the sample is about 1.36.
Finally, to test the pH of another sample's unknown pH solution, place the pH meter in the beaker with the unknown and read the pH. The pH for this sample is about 4.60.